Alrighty, so here we are on lesson 21, writing and evaluating expressions, and today we are using multiplication and addition. So we're kind of combining everything that we did in lesson 19 and lesson 20 and putting it all together to write expressions. So if we look at example or exercise 1, it says the Italian Villa restaurant has square tables that the servers can push together to accommodate the customers. Only one chair fits along the side of the square table. Make a model of each situation to determine how many seats will fit around the various rectangular tables. Okay, so we're going to start off plain and simple here with just one table. So with one table, if we put some dots around it, around my one table, this is 1, 2, 3, 4. So around one table, we would be able to put 4 seats. So go ahead and put that in your table. Now, if we had 2 tables pushed together, if we put our dots down, we've got 1, 2, 3, 4, 5, and 6 over here. So that means we could put 6 around 2 tables. If we do 3 tables together, we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 seats go around 3 tables. Okay, if we look at the patterns going down here, around 4 tables we would get 10 seats, and around 5 tables we would get 12. Alright, but then we jump to 50, and I don't think any of us want to draw 50 tables. I don't either. So I'm going to draw a different visual up at the top here. Alright, and I'm just going to make it one long rectangle. So if you look at all of our other drawings, it's pretty easy to see that the number of tables you have is the number of seats you get on each side. So here on my long sides, I would get 50 seats on each one. Alright, but then you also have to remember your ends. So this is another 1 seat, and this is another seat. So for 50 tables, we would have to add all these up, so it would be 102 seats. Okay, so if we take a look and we want to start looking at our pattern, we realize that we had to multiply our 50 by 2 and then add our 2 extras for the ends. So we're going to do the same thing for 200. If we multiply by 2 and then add 2, so 200 times 2 is 400, plus those 2 end seats is 402. So if we were to write an expression, we would have 2t plus 2. Right? So it says here, it's impractical to make a model of 50 tables together. So if we had a rectangle that long, how many chairs would fit on the long sides? We already did that. It would be 50 chairs on each side. And then it says how many chairs fit on the ends of the table. And that is always 2 chairs, no matter how many we put together. And then if we recorded it, we did in the table, it was 102 fit in all. So now it says if we let t represent the number of square tables that make one long rectangular table, what's the expression for the number of chairs? And we decided that was 2t plus 2. So what if we have 60 tables? So we know t stands for tables. So we're going to take our expression and plug in 60 for t. So 60 times 2, then plus 2, order of operations. We need to do 120 plus 2. So in total, we would have 122 chairs. Okay, so that's the first example. We're going to go ahead and flip over to the back side of your packet. This is the last page. And this example says, determine the cost for various numbers of pizza and also determine the expression that describes the cost of having P pizzas delivered. So part A says Pizza Queen has a special offer on lunch pizzas, $4 each. They charge $2 to deliver regardless of how many pizzas you have ordered. Determine the cost for various numbers of pizza and also determine the expression that describes the cost. So, if we have 1 pizza delivered, we know it costs $4, so times 4. plus that $2 delivery fee. So our total would be $6. For 2, they cost $4 each, so that would be $8, plus our $2 delivery fee, so this would cost us $10. We have 3 pizzas. They cost $4 each, so times 4, which is 12, plus that $2 fee, which gives us 14. For the same thing, we multiply by 4 and add 2. 4 times 4 is 16, plus 2 is $18. Alright, now we go up to 10. So 10 times 4 is 40, plus that $2 delivery fee, so this would be $42. 50, it costs $4 each, so times 4, which is 200, plus 2 would give you a total cost of $202. So now if we write an expression, again, we're still multiplying by 4 and adding 2, but we want to put that 4 in the front, so 4p plus 2. Alright, it says, what mathematical operations did you need to perform to find the total cost? So first we multiplied, and then add. Alright. The next part says, suppose our principal wanted to buy a pizza for everyone in our class, determine how much it would cost. So let's say that there's 25 students. Okay, so we're going to take that, and let's say we need 6 pizzas. So we're going to take our expression, 4p plus 2. Now we need to plug in the number of pizzas. So 4 times our 6 pizzas, then plus 2. 4 times 6 is 24, plus 2 will give us a $26 total. Alright, we're going to skip part B for now, and we are going to do it in class. Alright, and now we're going to look at part C here. So C says, if the pizza price was raised to $5 and the delivery price was raised to $3, create a table that shows the total of cost. Alright, so this is very similar to the one we did up above, but now we have a different cost. So if it was one pizza, it cost $5, so times 5 plus that $3 delivery fee would give us a total cost of $8. Alright, I want you to, on your own, finish the table. And if you get confused, look up at the example at the top of the page to help you. But I wrote down the operations you're going to do, and then we'll do some more practice in class tomorrow.